In this video, I'm going to show you the steps for connecting an Arduino Opta to the Ignition platform. So, step number one, you have to download the Arduino PLC IDE. I will not explain how to download here, but I will leave a link for downloading this. Step number two, you need to create a project. In new project, you will need to name this project, assign a directory, and select the target, in this case the opt. I will not create a project as I already have one. I will open my existing project. Um, if it's the first time for the Opta, you need to download the bootloader here. Make sure you have that done and push the reset button so it initializes properly. Then the next step I will do is connect to my target. As you can see, I have an Opta with Wi-Fi RS485 Ethernet. You can check your communications on the setup communications. I'm using the USB Type-C port, so I will need to check Modbus communications and make sure these are the properties that you have. So your virtual COM port, the baud rate, the frame, the address. You have to take into consideration that we have two COM ports. When you download the bootloader, you will select the second one always. Okay. Then on this example, I have some parameters which in Modbus are the input registers. So this would be input registers and status variables would be holding registers. Right now I'm only showing input register example, so I have this here. Then I have some programmable inputs. I chose for the four first inputs to be analog, and I will map them to these variables here. Then I have the LED green output as well mapped. My Ethernet port is configured as Modbus TCP slave. It's always enabled. Actually, I'm not using the Modbus TCP master. And then we need to make sure that on the sketch we have this configuration properly. So I'm using the Ethernet port here on the sketch. We're giving the Opta the IP address, the DNS, gateway, subnet. Actually, DNS doesn't matter much for this example, but the IP address, gateway, and subnet do matter. So you want to make sure you have this according to your network configuration or your field bus configuration. And then we will switch to the PLC program here. So I have a basic PLC program which only shows a blink for the green button. We have a network here that it's blinking the LED, the green LED, sorry, and just a basic mapping of the analog inputs to the input registers here. So I will monitor the program here. You can see the green LED blinking with 1 second period here. And then we have here the analog mapping, so the first one I'm multiplying by 100, you can see here. Then the other ones are just, it's just a basic move. And that's about it on the PLC ID. I will switch now to the Ignition platform. And so in the Ignition platform, you have to go to device connections on the OPC UA. Right now I have a connection already created, so I will show you my configuration. You might want to give a better name than this. I just call it Opta, Arduino Opta connection. it is enabled. This is the IP address for Modbus. We know that it's always the 502 port. Uh, Local address, we can leave it blank, and timeout communication, 2 seconds. So save changes. This will acquire this will make the connection to the Opta, and as you can see, it is already connected. So this is good. And then I will go to the quick client to subscribe to my variable. So this quick client, what it's doing is that via Modbus, it is creating an OPC server. So this is my native Ignition OPC server. I'm going to the Opta analog inputs. Oh, there is another step that I forgot. I will explain briefly. Okay, so you can see here my analog inputs. And as you can see, we have now the first communication. We have all the communications here, all the tags. Um, so as you can see, it matches correctly our program. The first one is multiplied by 100, and then the other ones are just as well. So this is actually noise. I don't have any sensor connected to any of those inputs, but you can see that it's already acquired that data and sending it to Ignition. Now, I will return to the device connections because here we have the addresses mapped. So I'm using a prefix called analog inputs, which is reflected in my OPC. So that's what is called analog input 1, analog inputs 1, analog inputs 2, analog inputs 3, and analog inputs 4. So I will start in the first one, I will end in the fourth. The unit ID, as we said before, we have an Ethernet port here and showing us the unit ID, which it is 255. And then the Modbus type. This is an input register of the int16 type. This is very important. So this is an input register. If I would want a holding register, I would need to add to status variable and then change here to holding register and the correct type. And it's also very important to notice that the Arduino slave only handles input registers and holding registers. So no coils, no inputs, discrete inputs, only these ones. This is a Modbus offset address, so I will start in the 16384 according to my parameters here. And what this does is that it will map this to the number 1 and then will move 4 addresses after. So it will end on 16387. Okay. I will go again to my OPC quick client, and this is already mapped. So this is my Opta, and these are my 1, 2, 3, 4, which internally are wired to address 16384 to 16387. And again, we will subscribe for this. And that's it. Okay. So this is how you do it via Modbus TCP for the Arduino Opta.